This presentation is about electronic mail. Specifically, we're going to talk about SMTP, POP, and IMAP. So once we get through this set of slides, you'll be able to understand 4 configurations of email architecture, the functions and formats of a user agent, MIME and its capabilities and data types, the functions and commands of an MTA, the function of POP3 and IMAP 4. First, we're going to talk about architecture. To explain the architecture of email, we give 4 scenarios. We begin with the simplest situation and add complexity as we proceed. The 4th scenario is the most common in the exchange of email. The topics discussed in this section include 1st scenario, 2nd scenario, 3rd scenario, and 4th scenario. So here's a picture of the very first scenario. UA stands for user agent, and that's a very common acronym that you need to know. It might even be on a quiz. So Alice is actually part of the whole user agent experience. She is taking whatever email document she's got and she's sending it. It goes through whatever system there happens to be. And in this case, it's pretty much just a black box, so you can't really see any kind of details. And then Bob is a recipient. He's also acting as a user agent too. His system is receiving an email. So essentially, this is the simplest diagram we could possibly come up with. Alice sends an email, it goes through the system, and Bob receives an email. So here's an important note. When the sender and the receiver of an email are on the same system, we need only 2 user agents. That would be Alice and Bob. Okay, so what we're doing is we're sort of setting the stage so you understand these 4 different architectures based on these 4 different scenarios. So here's a diagram of the 2nd scenario. As before, we still have 2 user agents. We have Alice on one end and Bob on the other end. In addition to that, now we're introducing message transfer agents. And on Alice's side, you can see an MTA client. Okay, it sends the message over the internet to the MTA server. Both of these MTA devices, while in this diagram, one MTA device is acting as a client and the other MTA device is acting as a server, they could just as easily switch roles, and one could be a client in the other server and vice versa, one a server and then the other client, depending on which direction the email is going. So here's another note to clarify things. When the sender and the receiver of an email are on different systems, we need 2 UAs and a pair of MTAs functioning as client and server. And here's a 3rd scenario. There's an MTA client mechanism that then sends that email. There's a local MTA server, which is also connected to a local MTA client. Then the MTA client, which is bundled with the MTA server, sends the email out over the internet. And just as before, an MTA server receives it and sends it on to Bob, who is the destination UA. So here's a note about that scenario. When the sender is connected to the mail server via a LAN or a WAN, we need 2 UAs, which we've had in the last 2 scenarios, and 2 pairs of MTAs, client and server. Now let me go back to that diagram. Notice that you see two MTA clients and 2 MTA servers. Finally, the fourth and most common scenario, Alice is still sending an email as a user agent. The MTA client mechanism then sends the email to an MTA server on the LAN or WAN. This is coupled with an MTA client, so they're coupled or bundled. Okay, and that's the system, that's the destination system for the UA. Then the MTA client sends out over the internet the email. An MTA server gets it. Something known as an MAA, or Message Access Agent, transfers the email to an MAA client mechanism, which then gives Bob the email. So there is this idea of push and pull. At the source end, the MTA client pushes messages to the LAN or WAN MTA server. The MAA client pulls messages from the MAA server. So you have both a push and a pull when emails are retrieved. So here's a note on that point. When both sender and receiver are connected to the mail server via a LAN or WAN, we need two UAs, two pairs of MTAs, client and server, and a pair of MAAs, both client and server. This is the most common situation today, mainly because it provides the most reliable and robust solution. Let's talk about user agents right now. The user agent, or UA as we've already called it, provides service to the user to make the process of sending and receiving a message easier. So in this section we're going to talk about services provided by a UA, UA types, sending mail, receiving mail, addresses, mailing list, and MIME. A user agent actually has 5 child processes. Obviously, one of the things it does is compose messages. That's maybe the thing that you think of most. The next thing it does is it allows you to read messages. Thirdly, it allows you to reply to messages. Fourthly, it allows you to forward messages. And lastly, it manages or handles your mailboxes. So here's a note. Some examples of command-driven user agents are Mail, Pine, and Elm. Some examples of GUI-based agents are Eudora, Outlook, and Netscape. So this gives you an overview of the format of an email. You can see in the top left, it's similar to a U.S. postal letter. There's a from address, Peruzan, De Anza College, Cupertino, California, 96014. That's the from, the source. Then Sophia Fagan, Comnet, Cupertino, California, 95014. So the first part of the email is the same. It has a mail from and a receipt to. Okay, and you can see that, and you can see the corresponding part of that envelope to the right. Then comes the header. The header includes not only the from and the to, but it also includes the date and time and the subject. This is actually the first part of the message. So finally the body comes. Body can be either plain text or formatted HTML. HTML actually is plain text, so it's in essence the same thing. Since HTML is text, it's a text-based message. It's either just some sort of unformatted text or HTML formatted text. So email addresses, you're all pretty familiar with these. There's the address of the mailbox in the mail server, which is the local part of it, at, and then the domain name, and the domain name of the server. And typically the domain name is not going to have the www dot. Normally it's just going to be the domain name, root.com or .net or .edu or whatever. So now let's say a few words about MIME. So you have a user agent who wants to send some sort of non-ASCII code. And this is actually not possible with email. Even though lots of times you attach zip files and you attach MP3s or whatever you want to attach, the email protocol can't handle non-ASCII data. So that's where MIME steps in. And MIME is a way of managing this and converting it to 7-bit ASCII code. So we're going to talk about this in more detail, but just to let you know, MIME is going to step in and convert binary code to ASCII code. And then it sends this to the MTA, the local MTA. And now the MTAs that are communicating, the sending and receiving MTAs, are only communicating in 7-bit ASCII. So because of the fact that the data is ASCII, the MTAs are successfully able to communicate. If you actually attach binary code, SMTP would prevent them from being successfully transferred. So the receiving MTA sends the 7-bit ASCII up to a MIME handler. The MIME handler actually converts it back to non-ASCII code, such as an MP3 or a zip or a JPEG or whatever it turns out to be. And then the user agent gets everything in one big package. How does the MIME handler carry this magic out? So it's got its own special header. And the header actually gives information, the MIME version, the content type. And the content type essentially can be, one of many things. On my server, if you look up the MIME types, it's got dozens of types, actually hundreds of types. Content transfer encoding, content ID. So these will actually all be filled out by real values, not just these generics that are sitting here. Content description, and then the actual email body. So here are the data types and subtypes in MIME. And the most common are going to be plain and HTML. Plain, obviously, is the easiest one because there's no formatting. HTML is still fairly easy because HTML is text. So it doesn't have to be converted or anything. Multi-part, sometimes a MIME payload is going to be mixed, so the body can contain ordered parts of different data types. It can be parallel, same as above, but no order. It can be digest, similar to mix, but the default is message. And alternate, parts are different versions of the same message. So let's continue with that discussion. So in the message, the RFC 822 specification says that the body is an encapsulated message. Partial tells you that the body is a fragment of a bigger message. External body says that the body is a reference to another message. Then you can have images. JPEG or GIF. Video can be MPEG. Audio can be single channel encoding of voice at 8 kilohertz. And that's even though you can attach MP3s. This is different. This is a MIME type that's part of the message body. Or applications such as PostScript or an octet string. So in addition to that, you can have actually content transfer encoding. And content transfer encoding applies to your actual attachments. And so this is going to be different than the MIME and the message body, not in the technical underpinnings, but in that it won't be part of the message body. So you can have 7-bit ASCII, 8-bit ASCII, binary non-ASCII characters, base 64, and we're going to talk about base 64 in just a minute, quoted printable. Since SMTP needs ASCII data to send, and it can't send binary data, it needs to have a methodology to turn any kind of arbitrary data into ASCII data. So it does what's known as a base 64 conversion. And to do that, first you start with the non-ASCII data. It can be ASCII. It's going to do the same thing whether it's ASCII or non-ASCII. But so let's just assume it's generically sort of mixed or totally non-ASCII data. And then you run it through a base 64 converter. And essentially what a base 64 converter does is it turns the incoming data into a bit stream. And it takes 6 bits at a time. Okay, and if you remember back to steganography, we talked about bit streams rather than byte streams. In saving and loading and transferring, we normally think of byte streams, but in this case, we're thinking about a bit stream. It takes each 6 bits. Now you have a number, okay, and you use that number as an index into a table that then gives you an ASCII value. So if you notice, you have these 3 non-ASCII bytes. And in the bottom row, they're turned into 4 ASCII bytes, Z, lowercase z, uppercase I, uppercase E, and 5. So it takes the bit stream and takes each one of the bit stream reads into an ASCII character. And this is the actual encoding table. So if you get a value of 0, it turns it into an A. Value of 1, it's a B, and so forth. And so this is just what's known in programming as a lookup table. You have a value which is an index into the table, and then you get the resulting value out. So this is actually how the magic is done, and it's a very fast operation. There's not much to it as far as CPU time, so it's fast enough that when you send and receive emails, it's not a big deal. So there's another way of doing it called quoted printable. If you'll notice, the data coming in up top is mixed ASCII and non-ASCII. So it's potentially more efficient to go ahead and just keep the ASCII data as it is. And if you only get some non-ASCII values, you can use what's called quoted printable to convert them into something that is ASCII itself. So this is going to be used mostly when your data is almost all ASCII. But let's say you have this middle. In the incoming data, you have 5 bytes. The middle byte is non-ASCII. And the reason you can tell that is because the most significant bit is set. Okay, so in order to turn this into quoted printable, you say equals, and then following the equal signs is 2 digits, which represent the hex value of this particular byte. And I have Wikipedia open that actually shows some examples, so let me see if I can get to that. You see here where it says an ASCII form feed can be represented by equals 0C, and an equal sign must be represented by equals 3D. Okay, so that's base 64 and quoted printable conversion. So now that we've had a little bit of background in email, let's talk about the SMTP. Let's talk about SMTP, which stands for Simple Mail Transfer Protocol. The actual mail transfer requires message transfer agents, which are MTAs. We've already talked about those a bit. The protocol that defines the MTA client and server in the internet is called Simple Mail Transfer Protocol, or SMTP. In this section, we'll cover commands and responses and mail transfer phrases and mail transfer phases. So this is an overall view of how SMTP is sent and received. You have a sender on a LAN or a WAN. The message goes out to a mail server. The mail server crosses the internet to the recipient mail server, and then the receiver on that LAN or WAN. And the receiver on that LAN or WAN gets the actual email message. So the MTA client sends commands, and the MTA server sends responses. And that's very important because there's always a command sent and a response sent back. Some websites, such as Hotmail and Yahoo, provide email servers to anyone who has access to the site. Mail transfer and retrieval requires the use of HTTP in those cases. This is a partial list of commands that the mail sender sends out. The first one is a typical hello, and this actually has to happen after the sockets connect. So then it sends out this misspelled hello command in the sender's host name. And I actually have had it, I've written email clients where I forgot to add that, I forgot to send out hello, and it still seems to work. I had one server though that responded with, "It's not nice to not say hello." So, and why it's misspelled, I don't know. Probably goes back 30 years to the beginning of SMTP when someone mistyped it or something. That's sort of the nature of these things. Mail from, the sender of the message. Recipient to, who's the intended recipient. Data, which is the body of the email, including any kind of attachments. Quit, reset, verify. No op means no operation. It's simply a way of testing the communications. Turn, expand, help, and send from. So the responses come back from the receiving server. Normally the responses in the 200 range are positive and everything's on track. 211 system status or help reply. 214 help message. 220 service ready. That's a very common response. 221 service closing transmission channel. 250 request command complete. That's probably the most common of these responses. 251 user not local. The message will be forwarded. Okay, in the 300s, these are positive intermediate replies. 354 start mail input. Now in the 400s, these are negative. These are negative messages. 421 service not available. 450 mailbox not available, and that's when you get maybe a message like if you try to send it to someone who doesn't exist. Sometimes we call this a bounce. Command aborted local error. 452 command aborted insufficient storage, and that's going to be rare in today's time and date. But at a time, that really was a possibility when servers and server space was a lot smaller. Okay, so these in the 500 range are really bad. 500 syntax error, that means whoever wrote your email client made some sort of mistake. 501 syntax error, here again, the programmer of the email client made some mistakes. 502 command not implemented. This is sort of an inadvertent mistake, not the fault of the programmer. 503 bad sequence of commands. That's where you might be sending an email, but you might have gotten everything out of sequence. 504 command temporarily not implemented. I've never actually seen that one happen. 550 command is not executed, mailbox unavailable. That might be if the mailbox just got temporarily deleted, or the mailbox might be full or something. 551 user not local. 552 request action aborted, exceeded storage location. 553 requested action not taken, mailbox name not allowed. 554 transaction failed. Okay, so here's the way it starts. The MTA client connects to the MTA server. Okay, and that's normally it's a socket connection, which if you're a programmer, you understand that. Basically, this happens at layer 4 and 5 of the OSI model, if you've ever had networking. It creates an end-to-end connection from one server to the other, whereby it stays connected while the communication is going on. Client sends hello, and the sender, MTA, responds with OK, 250 OK. And here's actually a pretty detailed map of how the whole conversation goes. So after you've done that, you have to send the mail from, you get an OK back. The recipient to, you get an OK back. You send a data command. It sends you back a 354 start mail input. Okay, now you send the header, which is the from, the to, the date, and the subject. Remember, we've already talked about that. So you send a blank line. Essentially, the blank line is going to tell the MTA server, the receiving server, that you're finished with a header. Then comes the message body, and when you're done with that, the server responds with OK. Finally, the client sends a quit to MTA server. MTA server sends a 221 back, service close. So that's an SMTP conversation and is pretty representative of what goes on millions of times every day. Now let's take a look at an example. So let's take a look at SMTP and how we send an email and simulate the commands and responses. So you can actually use Telnet to log into port 25, which is the most well-known port for SMTP, although some services use 2525, but we consider port 25 to be the reserve SMTP port. You can then use the commands directly to send an email. In this example, Farouzan B at adelphia.net is sending an email to himself. The first few lines show Telnet trying to connect to the Adelphia mail server. So you do this telnet space mail.adelphia.net space 25. Then it'll do a DNS lookup, get the IP address, and it'll say trying. Finally, it'll say connected to mail.adelphia.net with the IP address. So after connection, we can type the SMTP commands and then receive the responses as shown below. Okay, once you've connected, it's going to send you back a 220 and say the server is ready. And then you send a hello, mail.adelphia.net. Now, as I've said before, I've gotten away with not sending hello, but it's possible that a mail server will choke if you don't send the hello. So whoever wrote your mail client needs to make sure that they do it. Then the server sends back a 250 with its idea of its domain name, mta13.adelphia.net. Then you have to send the envelope. Mail from Farouzan B at adelphia.net. It sends you back a 250 sender and who it thinks the sender is with an OK. Recipient 2, you send this command. It sends you back a 250 with its idea of who the recipient is with an OK. Then you come to the header and body. You send the data command, and it sends you back a 354, OK, send data ending with CRLF, and that's basically 2 carriage return line feeds. So that's a 1310, 1310 if you're looking for what the actual codes are. And you send the from and the to. This is a test message to show SMTP in action, and you just send the 2 carriage return line feeds. And then it will send you back a 250 saying message received. You send it a quit, it'll send you back a 221 letting you know that it's closing the connection. And then it closes the connection and you're disconnected. So now we'll talk a little bit about POP and IMAP. So the third stage of mail delivery uses a message access agent. The client must pull messages from the server. Currently, 2 message access protocols are available: Post Office Protocol version 3, or POP3, and Internet Mail Access Protocol version 4, or IMAP 4. So SMTP, as we've already talked about, sends to the mail server, goes across the internet, and goes to the recipient's mail server. So Alice is the sender and Bob is the receiver. In order, though, to receive, Bob actually has to use either POP3 or IMAP 4. So here is a POP3 conversation. So the user computer, the client, contacts the POP3 server, the mail server, with the username. He gets back an OK. The client sends the password, gets back an OK. Sends the list command, and gets back email numbers and their sizes. So it's kind of a prefetch. It's letting the client know what it has available. So it sends a command to retrieve 1, it gets email 1 back. It sends a command to retrieve 2, it gets email 2 back, and so forth until it gets to the last email, sends the last retrieve command, and gets the last email back. So some websites, such as Hotmail and Yahoo and Gmail, provide email service to anyone who accesses the site. Mail transfer and retrieval requires the use of HTTP in these cases.